So today we are going to start a new chapter, and this is called circular motion. Circular motion is a special case of a motion called curvilinear motion. So we are going to study the circular motion of a particle, not a body, because a body will have its own motion called rotational dynamics. So there we study about the same. But right now we are going to only deal with the particle. So the dimension of the moving object will not be considered. So whether it's a truck or car or a mosquito, we have to treat everything as a point object and consider its movement. And if it is a body of some finite shape, then it must be replaced by its center of mass, which you will study later on, to study the circular motion. Okay. So because we are still into the particle dynamics, it is part of particle dynamics. So we consider everything as a particle. So even in case of body, we hypothetically replace a body by a point located at its center of mass. So this is what you will study later on. So for example, let's say if you have a ruler in your hand, if you simply turn the ruler, you hold at one end, you tilt it and then you release it. So how the ruler will perform the motion? So this is the ruler itself. And this ruler is kind of hinge. So if I drill a hole here and if I draw some axis, and if you release from rest, what will happen? The ruler will swing, right? And what is interesting here to know that while it is swinging, every point on the rod is performing circular motion. Do you realize this? That every point is going to perform the circular motion?
Yes, sir.
Because from the axis, every point will have the fixed distance, right? So no matter what, every point will perform the circular motion. The only thing is the radius of a particle will change. So the center is same, but the distance of particle is different. So oscillation of a body in that way is an example of a circular motion of infinite particles. And what I said that in case of a body, I will not deal with the infinite particle, rather I will deal with the center of mass. So from here you can, by common sense, you can understand that this is the center of mass. if it is an informed rod and all. And therefore, the only circular motion that we are going to consider is the center, and we are going to ignore the motion of other points. So that is the core idea of rotational, particle dynamics. So either you will deal with a particle, but if in case you come across a body, no need to panic. You replace the entire body by a particle and then you be comfortable. Just you deal with the things the way you do. So that is what I have written there. And this idea is very, very crucial when you will actually study the rotational dynamics chapter. So the same idea we are going to replicate, but as of now, you should remember that we are learning a particle dynamics. So the shape size of the body will not matter. We have to treat as a particle. And if you can treat as a particle, well and good. And if not, then you should replace it this way. I hope this part is clear to you, what I mean by the particle dynamics. Okay. Is this part clear to all of you?
Yes, sir.
So now I will put a more emphasis on the part called curvilinear motion. So we'll try to understand what is curvilinear. So a particle can move either on a straight line or it can move on any curve path, any curve track. And this curve track can be any shape. It could be any mathematical shape or non-mathematical shape. The idea is it can move on any curve path. So a path which is straight line, we call rectilinear. And any path which is not a straight line, by default, what we call? And you might be wondering why we are saying the word linear, because a particle cannot rotate. So when we talk about the motion of a particle, so when we talk about a particle moving on a curved path, then the velocity vector is going to be parallel to the path at that instant. So the particle will have a velocity, and this velocity will be tangential to the path. Is it clear what I'm saying? So our particle is moving. So our particle is moving, you can see here, and the velocity vector at any instant is tangential to the path. And in circular motion, the same thing happens. As you move on a circular path, what will happen? Your velocity vector will keep on changing, right? Isn't it? So whenever a particle is on a curved track, one thing is inevitable. And what is that one thing? The change of direction or change of magnitude or both? What is inevitable? What we can't stop from changing? Tell me, guys. So if you are running on a curved track, then what will change for sure?
Change of direction.
Change of direction. Exactly. And that is the property of curvilinear track. A rectilinear track will have a motion in which you may reverse the direction, but you can't change it in a sense. So one thing is clear that when a particle is moving on a curved track, then its direction is bound to change, yes or no? Hello, hello. Tell me, guys. When you're moving on a curved track, then your direction is bound to change, yes or no?
Yes,
sir.
Now, what does it mean? If direction is changing, it means what is changing here? Which vector is changing? Always.
Velocity vector.
Okay. And by definition of a velocity vector, if velocity vector will change, if velocity vector will change, then the body will develop what it will develop? Acceleration, right?
Acceleration.
yes, sir.
So can we say that a curvilinear motion is bound to be accelerated motion, no matter what?
Yes, sir.
So let's say you have a car, you're driving on this hilly area. Okay. So in a hilly area, you might have explained that it changes the direction constantly, if you have experienced ever. And this constant change, turning will create one acceleration. Because velocity vector is changing, it means the particle will have acceleration. Even though you try to maintain the speed of the car, can we maintain the velocity? So let's say you decide to drive at a speed of very small, 20 kilometers per hour in hilly areas. It's very risky. So if you drive at 20 kilometers per hour, can we say you're moving with constant velocity? Can we say? So on a hilly area, you're driving at a speed of 20 kilometers per hour. Does it mean you're not accelerating? So constant speed will represent acceleration, yes or no?
Depends on the direction and the path.
So for curvilinear path, even the magnitude of velocity is constant. Can we say velocity is constant or will be constant?
No, sir.
So that's why I asked you that what is inevitable, what we cannot control in a curvilinear path. Tell me, guys, what you cannot
So
control?
velocity.
You cannot control the change of velocity, right?
Yes,
The
sir.
velocity is bound to change. So the property of curvilinear path is that its velocity will change, and it will change for sure because of one reason, that is change of what?
Direction.
Direction. Now, what we can control? What we can control? So you are the driver of the car, so what you can control? If you want to move on a
Magnitude.
curve, yeah. So if you are driving a car, the only thing which you can control is the speed, which is like the magnitude of the velocity of the car. Okay. So you may control the speed. In fact, you can also accelerate or decelerate yourself in terms of a speed. But the direction is inevitable, it is bound to change. So what you need to realize that acceleration here can be due to either change of direction or could be due to change of speed or could be due to both. So in how many ways we can alter the velocity? So we can alter the velocity in three ways, right? The first way is called change of direction. Okay. And the second is called the change of magnitude of velocity. And third is called by changing both. So let's say if you are riding your bicycle on a roundabout and you're also pedaling it faster. So in that scenario, when you're doing it, what you are going to develop? So you're going to develop acceleration due to change of direction as well as change of speed, the magnitude of velocity. And if you're riding your bicycle, not changing the speed of the bicycle, so one thing is bound to change, which is the direction. So in that case, the acceleration is only due to change of direction. Now the question is, if someone is going this way, in common sense, if someone is going this way and now you want to turn this way, who will do it? Can we change our own direction? So that you will study in the later part of the, no, you have already studied. So Newton's law says that you cannot change the momentum without applying force. Can we? What Newton said, if external equals to dp vector by dt. Okay. So Newton says that the external force will change the momentum of a body. And how we write the momentum? So if I am changing the velocity, am I changing the momentum? Yes or no? Because in general, the mass of the particle is going to be constant. So in case of particle dynamics, so for particle dynamics, mass is a constant parameter. So momentum is directly proportional to what? Velocity. So as you change the velocity, momentum will change, yes or no? Hello, hello, hello. Yes or no, tell me. Hello. Am I audible, guys?
Yes, sir.
Yes, sir.
So if particle is moving on a curved track, then as the particle moves, its momentum will change, yes or no?
Yes.
And if momentum is changing, is it possible to change the momentum without applying some force? Is it possible?
No,
Can we
sir.
change our momentum like without taking help of anybody else?
No.
No. So what we don't realize in our day-to-day life that when you're riding a bicycle and you take a turn you're not doing it on your own. So to take a turn, you do a lot of things which you don't realize while riding bicycle. But you must have realized one thing, that you turn the handle, right? Have you realized you turn the handle? Have you realized? Yes or no? Have you realized? Yes or no? Tell me.
Yes, sir.
You don't understand what is going to happen, but you simply turn the handle and you expect that your bicycle will turn. And in fact, it happens in most of the cases. When you turn your handle, you certainly turn. But you can't turn, at the right angle. Okay. So the whole idea is there is a hidden force which is helping you in turning or negotiating the curve. And in case of your bicycle ride, can you give me the idea who is helping you in turning or negotiating the turn? Can you guess? Tell me. Tell me. Any guess?
Sir, reaction flows on the ground.
So you want to turn. So it's like someone is pulling you this way, right? If someone is going this way and turning this way, it means someone is pulling in which direction? You're being pulled like this. You do like this. And if someone is turning this way, so it is like pulled like this. So what you don't realize, when you ride your bicycle, it is the friction force between the tires and the road which actually determines the ability to negotiate the turn. And more the friction, easier the negotiation or the easier the turn you can accomplish. But imagine if a road is having some sand particle spread, it's very dangerous because you might turn the handle, but friction will not be sufficient to turn. So because of inertia, you will be thrown forward. So every time you turn your handle, you're at the mercy of the friction, whether that turn will be achieved or not. And I hope you might have also experienced that if you're moving really fast, it's very difficult to turn, right? Have you realized? So near the turn, you always slow down yourself. Have you realized this? Every
Yes.
time you come near the corner, you slow down, you apply the brake and then you turn. Else you will feel that you're going to, meet some accident. The question is, the higher the velocity, the greater force we need to make the turn. So if we fail to receive that much force by the ground, we certainly going to meet the accident. We are going to hit the other side of the road. We may fall down. A lot of things will happen. So generally, I mean, if you do not understand physics, then you will think that, okay, because I have a car, I can just turn the way I want. Okay. So recently, uh, there was a bunch of guys actually, and he was some minister's son. Okay. So their father were ministers in the government. And they bought a very big car because they have filthy money. So they bought a car and they were driving at a speed of maybe 100. And because they don't go to school, even in school, they don't study anything. So what is the thought that a car is a machine which can do whatever they want? And that's why I say studying physics is not only because you want to qualify in the JEE. Even to live a normal life, you need to know physics. So you know what they did? At a speed of 100, driving some car like Mercedes or some high-end car, they turn the car at that speed. They don't realize that they can't turn the car because they are turning the steering wheel. Certainly, you need to change the direction, turn the steering wheel, but that will not turn the car. Your car will be turned by the friction between the tire and the ground. And at that speed, it is impossible. Because they simply rammed in the like a building actually near the corner. And all gone to heaven on the very moment. So it was that such a huge crash. All dead on spot. So the idea of the story is you cannot, violate the rule of physics. You want to do something, please do. In your real life, if you're trying to violate the law of physics, you will go to heaven. But as an academician, if you break the law of physics, then probably you will win the Nobel Prize. So that was the whole idea. You cannot negotiate the turn because you have the handle of your bike or steering wheel of a car. No. You have to feel the ground support that you will get while you're turning. And that can be felt, most of the drivers who are very good drivers, they can feel that, frictional support which they are deriving from the ground. And as they turn, because they have felt those, we call G forces. So they know that what speed is sufficient, at what speed we can negotiate. Even in the F1 race, you might have seen F1 race. So near the turn, they either negotiate from the outer corner or they slow down. Have you seen that? Have you seen F1 race?
Yes, sir.
Now, F1 race is the best example to understand the circular motion. If you want to understand circular motion, go and watch any F1 race. And you will realize that, and especially the MotoGP race, if you want to understand the idea of friction, just see the MotoGP race. These bikes are moving at such a great speed. And if you see the shape of the tires of the racing bikes, it is very much flat and curved also near the edge. It's first of all big tires. The width of the tire is given really huge, and it is curved near the edges so that even if you turn, you will make a good contact with the ground. And these are very flat tires. Have you seen that tires? They don't have groove. A racing bike will not have groove, but a road bike will have a groove actually. So the question is why racing tires don't have groove? The reason is the racing bikes are meant for the racing tracks, and the racing tracks are very smooth. And these tires are especially designed tires. They try to maintain maximum contact because when they touch at a when they touch over the bigger area at high speed, because the tire is like a chemically soluble kind of thing. So the layer of the tire becomes gluey actually, and it kind of becomes sticky. And that stickiness creates additional friction. Of course, the laws of friction which we study F equals to mu n is not applied in the racing track, but you can also assume that it is applied indirectly. So the mu becomes mu s. You will come to know that the mu is there is mu s. So when you're looking at the motion of the bike or car, which friction do you expect? Kinetic or static?
It's the kinetic.
Have you seen in general, your car is scratching the road while moving?
Oh, no, sir.
You will never see. So when you run, when you walk, when you ride, when you drive, you will actually realize that these tires, your foot is not rubbing the surface. And therefore the friction nature is actually static in all cases. So that's why you will study rotational dynamics to understand the same. Okay, only when you skid, you rub the surface and then friction will come. Which friction? Tell me.
Kinetic.
Kinetic. So is this clear that when you ride, walk, run, drive, in all such cases, the friction is which nature? Is static or kinetic?
Static. Static.
You realize? Prashant, you realize?
Yes, sir.
Have you realized this ever? No. You might not have realized. So next time when you're on the nearby, standing near your road, or if it is possible to see some vehicular movement from your balcony or your window, spend half an hour some fine day only looking at the wheel of car, truck, bike, and that day you will learn a lot of physics. So you will realize that none of the tires or wheels is rubbing the surface. They are simply kind of falling over the surface. So when you watch someone very carefully, a person running is actually falling. And how they fall? So take a stick and simply drop. So if you have a stick, and if you drop, so it will start falling, keeping the bottom fixed, and then after some time the bottom will also lift. So you might have seen this. So when the stick is falling, this point is not moving. You might have realized. Or you can realize in the ultra slow motion. So if you have a camera with slow-mo, you drop something, let's take a stick and drop it, capture it, and watch it. It's very interesting exercise. You have the camera with slow-mo feature? You have, guys? Tell me.
Yes,
Yes,
sir.
sir.
Because you guys post so many pictures on Instagram, Facebook in your day-to-day life. Do use this camera for some good purpose. So take a stick and drop on a floor. Especially it's good to drop on a bed because the bed will kind of hold it better. And drop it and capture it. It's more exercise and then you can see something. So once you are done with the experiment, just let me know. So in the ultra slow motion, you will see that the bottom is not moving for some time. Tell me, guys, are you done with the experiment?
Yes, sir.
So what you observed? Can you see the bottom is not moving for some time? Although the
Yes, sir. The position is the same until it hits the ground.
yeah. So you can see that there is no relative motion between the point of contacts, right? So body as a whole is moving, but is the point of connection, the point of contact moving relatively? Yes or no?
No, sir.
No, sir.
And if there is no relative motion, if there is no relative motion, what does it mean? The friction will be static or kinetic? Which friction we can think of?
Static.
Static. Now imagine a wheel as collection of sticks. So this is the wheel. The first stick is this one. And as it falls, actually what happens, the stick doesn't move, but after elementary fall, the point which is kind of elevated. So if I draw, a bigger one, let's say you can see this point is quite above the ground, right? So when it will fall, what will happen, the new point will become the new contact point and the previous point will go in air. It will go above the surface. And this will happen at elementary level, so you won't feel it happening actually. So it is happening every time you turn by d theta. A new point comes into the contact and the old point goes back in air. Do you realize this? So every time a new point will make a touch, isn't it? So as the wheel will turn, the front point which is not touching the ground will touch the ground, and the old point which is touching the ground will go above the ground. Do you realize this? Tell me, guys, yes or no?
Yes, sir.
And this constant, touching the surface and leaving the surface, it happens seamlessly, which means it is not happening discreetly. It is happening without your realization that a new point has come into contact. And in the whole process of leaving the surface and touching the surface, so old point will leave and new point will touch it. Do they move relatively? Do they rub the surface? Is there any relative motion between the surface? Tell me yes or no. Do you see
No,
any
sir.
relative motion here? The answer is no. So every vehicle with tire, they don't move relatively. Rather, they fall forward. and they create new contact and the old contact leaves. Exactly same phenomena happens when you walk. So your front, let's say this is the the foot touching the ground, and this is a foot which is waiting to be touched. So as you walk, you kind of lift your foot because the two foots are joined near the hip, and then the rest of the body is here. And so these 2 foot, one is touching, you lift the one and you touch the other, which is exactly like the motion of the wheels. But you have to repeat the process because you don't have the luxury of wheel, because wheel will have infinite foot. You have only 2 foot. So you use this in oscillation, right? You oscillate your foot back and forth. So as you walk, what you do? You touch the front, you bring this into contact and you lift this back one, right? And you repeat the same process, yes or no? Hello, hello.
Yes, sir.
So when you're walking, which kind of friction is active? Is static or kinetic?
Static.
No. So are you all realize this part? Tell me yes or no.
Yes, sir.
So the whole idea of circular motion is, first thing is you have to realize that what kind of friction is acting. So most of the students think that okay, motion means kinetic friction and rest means static, which is not the case. In our day-to-day life, we don't understand the actual idea of motion. Motion as we perceive and motion as it is happening, these are two different things. And only with the help of physics, you will realize that, or you can decode the exact way things are happening in and around you. And this observational skill, which we develop over time, that is what makes you a physicist, a scientist from the rest of the crowd. So Einstein said once that science is to see that everyone else has seen. What is science? Science is to see what everyone else has seen, but to think that no one has thought yet. So a common person, a person with observational skill, they see the same thing. The difference is what they think. And the moment your thinking comes into picture, you become scientist, you become physicist, you become a person with a rationality of everything. Elon Musk said that physics is the one of the best framework to think. So in the world, nothing can develop thinking more than physics. I'm not saying. Elon Musk said, because I know you will not believe me, so at least you can believe that guy. So physics is the way to develop thinking. It is the only framework available in the world which can create a very rational thought process, a thinking process. And the more you study physics, you actually become more rational or philosophical or real to this. Okay. So the idea of learning physics is to develop your thinking process. And if a person has developed the thinking process, he can qualify in any examination. He can crack any examination eventually. He can crack any unsolved problem of the world. Because when we face with unsolved problem, we start our investigation from the laws of physics. That if this is happening, then why this is happening? Okay. So sometime back, I was playing with the hair dryer with a ping pong ball. So if you take a tennis ball and take a shower, remove the front cap so that you can have a bigger area. The ball will float under the air pressure. Yes or no? You can do this experiment. The tennis ball will float actually. And what is more interesting, it will not float because the blower is this way and the ball is here. No. Even if you turn your blower at almost 60°, the ball will float like this. Have you seen this? Okay, you might not have seen. So even if you hit like this, the ball will not fall down. It will remain there. Do you know this fact? It remains there. So you may say, is it magic? The answer is no, it's physics. And to understand the explanation of this physics, you have to go to a chapter called fluid dynamics, and there we'll study all this thing. I shared the video. I recorded that video in one morning. Let me share it. You can watch this later on. So everything is physics. Physics is like it will give you the idea that why things are happening. So if the airplanes are flying in air, it is not a miracle. It is the law of physics. And we are able to do this because we have decoded the nature. Most of the physicists, they have discovered things. They never invent things. They only discover. So the absolute knowledge is always there. We have to discover that knowledge. We don't create knowledge. So when you observe something really carefully, you discover something. And that discovery will add to your knowledge. So you become genius because you have discovered many more things than the normal guy. And that is the journey of becoming a scientist. You're not supposed to born intelligent or something. You're supposed to just be a good observer. And every scientist having this natural trait, they are extremely good observer. And then, they don't only observe in the real world, they also observe or make their observation in the meta world. Like they keep on thinking, they do the thought experiment, and they create their own logic. They talk about the reality, realism. So a lot of philosophical thinking, which many philosophers or saints were aware of. So in context of, you can say, Indian civilization, we had a literate saints actually, and they were knowing a lot of things. Okay. In Western philosopher, they also have the series of philosophers. So you know the name of Aristotle, uh, Galileo. They were philosophers actually. So in the earlier times, the philosophers were the thinkers actually, and so they become the logician, thinker, rationalist, and they become eventually scientists. So scientist is a way of saying a particular domain actually, but they were philosophers. So Archimedes was a philosopher. So in the old times, the philosophers were the mathematicians, they were the scientists, they were the physicists, they were the chemists, because they all were philosophers. So they used to talk about the knowledge, ideas, and so many things. The same thing is happening till date, but now it has taken a dive actually. Now we are not producing good thinkers. We are actually training students mostly to crack examination by doing certain way of things, and they are failing to develop themselves, in terms of thinking. So they are giving some sort of, shortcuts that you do this, you'll get this answer, you do this, you get this answer. And they are also happy because they are getting marks, numbers. And the only way for today's parent to judge their performance of kid is the numbers. And no one is bothered about the understanding of concept, understanding of ideas. So we are getting, manufactured into non-thinking, repetitive, work doing slaves. So we are good for doing job of certain repetitive nature. But when it comes to the new thinking, new ideas, most of the Indians are failing. And from the recent data also, the mathematical thinking has taken a deep dive in India. So hardly students are getting interested in mathematics. They have stopped thinking mathematical. And that has turned out to be a biggest problem for the coming century. So the mathematical genius that we were actually, India were a mathematical genius. We had students, doing extraordinary in mathematics. And there are many students from the Indian origin who has won the field prize. Field medal is like the Nobel Prize of Mathematics. And recently, few years back, you don't know, a monk won the India's best mathematical prize, the Infosys prize. So now only the monks are doing the mathematics because they are really calm thinker, they are good thinkers. But individuals has stopped. Okay, so as a country, we are kind of declining in the mathematical thinking. And that will lead to a lot of issues in future. So we will not have any computer scientists in the future. Only the old few which we have, they will rule. And mostly we are going to produce the slaves, okay, not the thinkers, so which is the biggest concern for the future. And everyone is happy. The problem is not you, the problem is the environment, because everyone is encouraging that way of thinking, that you don't go deeper into thinking, you just mug up this thing, qualify the examination, get some marks, and go to some engineering colleges and do the all the 4 year shit and then come back. And then go for MBA. And then become you know, a leader. So this is how things are happening. So India will never have the Elon Musk moment. We will have mostly the CEO working for someone. That's it. So anyway, why I'm sharing this, because I want some of you to become rational and do something really good. Not just for the country, for yourself also. A thinker will make you extraordinary. And I believe that every person is having that thinker. The thing is, they don't want to, evoke that thinker. They are dormant kind of thing. You have that thinker. You will start, observing things from day to day onwards, and you will start seeing the change. You have to listen to every line said by the teacher and decode it. And you should not be relaxed unless you have not decoded what I'm teaching. If everything is making sense to you, you are lucky. But if not, then you have to spend time and decode it, like what is being taught by teachers. Why they are saying what they are saying. Why sir said that this will happen this way, and then I have to remember. You have stopped questioning. The difference between the education here and education abroad, if you go abroad, the class is not calm. They have counter questions. So I have seen that in MIT or in Harvard, the students are very vocal and they ask very real, legit question. They don't accept what is being said by teachers. They counter question because they know that, okay, this is not rational. It is going something like sir has said, and I will not believe it. And that questioning ability is encouraged in the, you can say the West counterpart. So the best Ivy League college, they encourage the counter question. Here we threaten the student if the counter question. You stick to your syllabus, you stick to that. And eventually, because this is happening since class 6 and 7, they kind of stop thinking. They start believing what is being said, and if they simply reproduce those ideas back in the examination, and they got good marks. Because if you follow a teacher, then teacher will be very happy in school and will give you good marks. Because what he said or what she said, you exactly replicated, and they are very happy that okay, whatever I said, and that's why they will believe that you are a genius. So this rote learning has kind of uh, completely ruined the entire generation of learners, and this is done by a school only. The school, we have teachers who emphasize mostly on the rote learning, that you solve these many questions which I'm giving you as a sheet, and then you become genius. Parents and students both believe the same, and you will become genius by doing all those things. So maybe you can break this disorder and become an independent thinker. And if one of you will become the same, then my purpose is achieved of teaching. So I'm teaching for only one purpose. I want to break the shackles of thinking. Every student who comes to me, my whole purpose of teaching is that they should not be trapped in this the pseudo learning process, which is developed by schools or uh, many teachers, the rote learning method, because you're getting marks, so you're happy. All these things are like shit only. You develop your own ideas, you think freely, counter question your teachers, and extract the real knowledge. I'm giving you the liberty, but you have to come with some really good questions. You can't answer, can you please explain the last slide? Can you please explain the last question? You're not asking question. You're disturbing the class in that. Because your doubt cannot be questioned. Doubts are concepts. I appreciate it when a student asks doubt. The irony is no one has asked me doubt. I mean, rarely someone asks me real doubts. That why this? Why not this? Why you thought this way, not this way? And when this thing happens, then I know that the guy has developed the thing. Very rarely happens. So most students, they think that asking question is asking doubt. Everyone is unaware of this fact. That asking question is not asking doubts. Asking question means you have understood nothing. You haven't developed ideas, and it will take a lot of time to decode this part of your learning process. It takes a lot of time. And every individual has to work to develop this part. So let's say if I tell you that can you study a chapter which is, let's say there is a chapter called work energy power. I haven't taught you. Do you have the ability to go and read on your own and understand the entire chapter and solve at least 80% of question or 70% question without being taught by any teacher? Have you done this ever in your life? That you go 2 or 3 chapters ahead of teacher, you finish things as much as you can, and you wait for the teachers to come and teach something which you missed in that chapter, some theory, some concept. Have you ever done this for any subject?
Yes, sir.
Okay. So for which subject you did, Shidant?
Sir, in school I've done this.
Very good. But have you ever done for the IIT-JEE preparation?
No, sir, not.
And there you failed. This thing has gone from the student. I mean, what you think that I will teach and then you will learn. So in a way, you have kind of given up. You don't believe that you can also learn on your own. This chapter is not taught by teacher, so I can't learn. What is this? Let me tell you why we are teachers, what I did. Before every lecture, I used to finish entire Iroda and most of the Isvarma. Imagine I'm finishing the Iroda and Isvarma on my own, at least 70% before going to class. And I used to wait for my unanswered question. So things which I have not answered because I was missing some concept. And then while listening to the teacher, I came to know, okay, this was what I was missing actually. That sudden realization that I was missing this idea was sufficient me to, solve the remaining question. So in every lecture, I used to wait for my missing part, that what I didn't learn in the class or in the book, what I didn't decode actually. And that constant vigilante, okay, that I am waiting for the things which I missed. My brain is very much alert that I am waiting for this. And the moment sir said something or he solved the question, I got all ideas. So it simply become like a crystal clear in the brain. Okay, this was what I was missing. And then I came back home and then I solved the remaining. This was the idea. And were we studying in all coaching? No, I studied in a coaching where teachers used to teach only mechanics. I mean, in physics, they will teach mechanics, not much more than that. I studied in maths where teacher was only able to teach up to limit, continuity, and differentiability, only calculus. The rest he said you can learn on their own. So they believe that okay, I can learn trigo on my own, coordinate geometry on my own, everything on my own. So he said, I will teach you a basic calculus, which is sufficient for thinking, and a complex number. And he didn't teach beyond that. He said, okay, rest you can learn on your own. And in chemistry, I mean, okay, anyway, in chemistry, I studied more than a teacher. That's a different study altogether. The idea was I was very much ahead of classroom, very much ahead of teachers also. Because I was having the self-learning ability, which I developed. Okay. So I realized one thing, that how to learn actually, how things are created from the scratch, how you master a chapter from scratch. So what are the techniques which we employ to understand the chapter? So of course you should have a good collection of books at home. So you start reading the book. At one go, you finish the entire reading. So when you start a reading of any chapter, a reading must be completed in one sitting. You can't study in 2 days, no matter how much time it takes. So you have to finish in a single sitting. Don't start if you can't finish. Once you start and finish in a single sitting, you will come to know about the basic concept of the chapter, and then goes the second revision. Because when you study for the first time, it is difficult to relate what is going to be written forward and what was written already. So as a beginner, we don't realize that what is the connection from the first sentence to the last sentence of the textbook. And when we reread, then connections are established. So this concept is attached to this concept because you have already seen this. So we also, as a student, we decode the process of interconnecting the ideas, and that comes in the second reading. The first reading will take, let's say, X time. The second reading takes only X by 5 times. That's the whole idea. In fact, a book, which may be a 600-page book, I'm saying 1,000-page book. The first reading may take 6 months, but second will take only, how much? 1 month. And third takes only 15 days. A 1,000-page book you can study in 15 days. But first you have to establish the connection by reading it thoroughly over the time of 6 months. So the first year of learning is not about writing examination, which is a bad practice. Okay. The first year is about connecting the concept first. So you only spend time in connecting the concept, and then you revisit the things. So in the 1 year, actually, you can finish the entire syllabus of physics, chemistry, maths, because you have established the connection. Once your ideas are developed, once you know the concept and its correlation, because you have worked really hard for it, you know how to develop the ideas. First of all, you have decoded this part. Then comes the practice part. So while doing this, of course, you're solving the entire book, but that time you will do it and kind of you will forget a lot of things. In the second time, because you have done this already, we develop the relation, the connection. And because over the time, your subconscious brain will also absorb and recreate some more ideas. So because you have spent a lot of time subconsciously on the subject, the second revision will become very powerful. So it will take almost no time. And then ideas will kind of get stuck in your brain. And when you're doing for the third time, which is very close to the examination, it will become concrete. Now, this is the self-learning process. Now, you're not supposed to do this much hard work because you don't have time. That's why you're into coaching institutes or you're with teachers, where we may give you the all connection, the future, the present, the past. So your effort of reading books is gone. Okay. But this is not good. As a teacher, I will try to reduce the effort. But as a student, you should not do. This is, I'm saying you off record. It's like under the hood. No one is going to tell this secret. Because if you are every day dependent on your teachers, it is very harmful. It means you're not going to succeed, which is guaranteed. No one will tell you this. A dependency is dangerous. A self-learning process, reading habit is essential for very good rank in IIT-JEE. And go and read on Quora about any student who has got into top 100, top 200, top 500. The one thing which is common to all of them, they read a lot of books. It is not said they were also going to coaching, but they use coaching for other purpose. They use coaching for practice, problem solving, and to extract the knowledge from teachers, which is not, readily available in the books, to get some insight about the subject, about the topic. So they use their teachers in a different way. A regular student, they don't do the same. What they do is they wait for everything in their life. They wait for their birthday, they wait for their, teachers to teach the topic. They wait. They only wait in their life. They don't initiate. And that's the biggest difference between rankers and those who don't get a good rank. The initiation is very crucial. Do you take so much, like, let's say, this year in 2022, JEE Advanced happened. Okay. How many of you went and searched the question paper of JEE Advanced and tried to figure out what is written there and how much you can do? Were you so much curious to see all question paper? How many of you saw the paper of this year IIT-JEE?
Sir, I tried solving the math section.
Very good. So did you, okay, because that time you were studying the mathematical tools, right?
Yes, sir.
You have the curiosity. Let's say when you finish the laws of motion, did you went for all the previous year question from the IT, which was asked in the laws of motion? You tried to, you had the curiosity to go and explore and see what they asked, and with your learning, can you solve those questions? Have you ever got this kind of curiosity to go and solve, search about questions? If the curiosity has not developed, you're not into JEE Advanced preparation. Like, we were mad. That time there was no online kind of thing. So my preparation was before this internet era. Of course, internet had come, but in the metro cities, which is very expensive. So the whole idea was we have to figure it out by reading textbook only. So we used to collect the old papers. Okay. And with that, once we had the paper, we used to explore the paper. How IT asks question, what they do ask, what kind of question they ask. Okay. Can I solve with the knowledge? Why I'm not able to solve? And because we had the right question, we got the right answer. Because we were not dependent, we were independent thinkers. And I'm saying as a student only, don't think that, okay, that time I was teacher. So definitely 20 years back from now, I was writing JEE. I was not a teacher, right? So 20 years back, I was just like you guys. Just like you. You're 16, 17-year-old guy, that's it. So the process we decoded. And why? Because we were curious to understand things. I really wanted to understand what is happening in physics, chemistry, maths. So I was not, solving question for marks or something. I was not giving the excuse that tomorrow I have examination in the coaching class, so I will not solve. That attitude was not there. So we learned a lot in the due process, even though we don't have the best of the teachers and best of the things. We decode the books actually. And in fact, I have discussed about the reading habit. So how many of you have started the reading part in physics, chemistry, math? Do you read?
Yes, right.
So the topics in which you are really weak, you must start reading. So let's say if you can understand physics with ease, read chemistry. If you're very poor with physics, read physics then. If you're poor with math, then start reading maths. You have to read the theory, the derivation of mathematics, how it came into being, how the formula came into picture, how the formula can be derived actually. And if you're not doing these things, then still you're not learning. You have to change the process again. I'm saying. With 40% syllabus of maths covered, with 40% syllabus of chemistry covered, with 70%, of course, because physics is something really, you can say, dependable subject, because in physics, if you know the concept, you can definitely solve the question because nothing goes beyond the concept. In chemistry, it can go anywhere. You have no control over the concept. And in maths, it could be tricky in any possible ways. So the idea is with 40% of two subjects and 70% of one subject, you can qualify IIT-JEE advanced. It is not difficult. IIT is actually easy. Mains is more difficult because in mains, you have to cover every chapter 100%. So you should know 100% of syllabus. In advance, you should know only 50% on an average, all the syllabus, all the 3 papers, physics, chemistry, math, and you're done. And for 50%, if you do the rigorous study, that's good enough. So you will not get marks in the examination in the school, college, but you will qualify JEE, still will qualify JEE. So what you need to check is that, okay, you understood one chapter, go and apply in the JEE questions. If you're able to solve, you're done. Okay. So I hope the process is clear. How to study anyway. Coming back to this part. So when you're walking, riding, driving your car on a curvy linear track, every moment someone is helping you to negotiate the turn. Someone is turning you. You're not doing on your own because Newton said the same. To change the momentum, we need external force. And the idea is how to discover that external force. You have to develop the intuition. You need to see the ability mentally. And if you can see the ability, then you can actually discover that the hidden unknown force. So question is, a velocity vector can be changed in two ways, either by change of direction or by change of magnitude. Okay. So if I have a curvy linear track, okay. So we'll go to the high school mathematics, which you might have remembered. In class 10th in geometry, you study one property that from the three non-collinear coplanar points, how many circle can pass? If you have 3 points which are non-collinear but coplanar, then how many circle can pass? Can you guess? Okay, you don't know this geometrical idea. Okay, you remember the theorem? See, the chapter of circle, this was the theorem. From 3 non-collinear but coplanar points, only unique circle can pass. Anyone knows this? No nodes. So how to construct that circle? Any idea? Let me make it darker. If I give you these 3 points, let's say some random points. How to draw a circle passing through the 3 points? You know construction?
So their perpendicular bisectors will intersect at a point. That will be
Correct.
the center.
Any 2 points of circle will make a chord, right? So basically these are 2 chords. And if you bisect the chord, it will pass through the center. This is what you said, right?
Yes.
So the perpendicular bisector of every chord, I'm hoping it is perpendicular, roughly. So the perpendicular bisector of every chord can only meet at a point called center. And the point is lying on the circumference of the circle. So the center to the point will be the radius. And if you take a compass and if you turn, it will actually touch all the 3 points. You can do this right now also. You have compass right now? Anyone have it? No. So I will not guarantee here because it's difficult for me to somehow. I think this is how it will happen. And this is going to be the unique one. I mean, exactly one circle will pass. And then you say this as the radius of the circle. So this is how we studied this construction of circle from the 3 points in class 10th. Do you remember? Hello, hello, hello. So now in a circle, if I choose any random 3 points, and if I try to draw so for any triplet in this circle, we are going to get the same center, same radius, yes or no? Hello, hello. So on this circle,
Yes.
how many points we have? On circle, we have infinite points. But if you take any triplet of the points from this infinite point, every point will give you same circle, same radius, same center, yes or no?
Yes, sir.
So a circle is that curvilinear track having unique center and unique radius. So every curvilinear path will not have this feature, and circle is the unique one. So a circle will have unique radius and unique center no matter what. That is the beauty of circle. So in case of circle, if you choose any random points, 3 points, if you take a triplet of points from the bunch of points on the circle, or you can say circumference of circle, they will give you unique radius and unique center. So it's like a, even if you try to draw, it will coincide with the first circle. So no matter which 3 point you take, every time if you draw a circle, it will coincide. So circle is again a curve path with unique radius and unique center. But can we say the same for a random curvilinear point. So let's say if we talk about a parabola. So you all have seen parabola, right? So let's say this is a parabola. This is the vertex of a parabola. Now tell me, in a parabola, it is also collection of points. Yes or no?
Yes, sir.
How many points we have here? Infinite. So this is the general equation of parabola. You can add this way: y square equals to 4ax. So how many points we can have on a curve? The answer is infinite. And though we have infinite points, if I take a triplet of points, are we going to get the same center? Same radius? What do you think? So imagine these 3 points, just to understand the idea. One here, one here, one here. And if I try to draw a circle, what will happen? I will get some center here. But if I choose a point here, center will change, radius will change, yes or no? I mean, this
Yes,
is
sir.
a basic idea. The idea is a curve which is not circular. How many circle we can obtain by taking the triplets?
Infinite.
Infinite. So we can have infinite number of circle, and if you have infinite number of circles, you will also have infinite number of radius. In fact, it is good to say that every point on a circle will have its own circle. Every point on a curve will have its own circle. Now that is somewhat counterintuitive, that how one point can have its own circle. The answer is yes. A point can have one circle. And the radius of this circle is called the radius of that point, which we call radius of curvature. So a curve will have infinite circle, and the radius of the respective circle at a point will give you the infinite radius of curvature. But the question is why I'm saying that one point will have circle. For circle, how many points we need? Tell me, guys. To draw a circle, how many points we need?
So 3 points.
We need 3 points. 3 distinct points, right? So we need 3 distinct points, which should be non-linear and should also be coplanar, which means in the same plane, right? And then we can draw a circle. Yes or no?
Yes, sir.
So now imagine this is a curve, and if I choose a point O, a point right to this is called O plus, and the point left to this is called O minus. You know what is O plus, O minus? This is the mathematical right-hand limit, and this is the mathematical, and this is the point. And if you remember the limit chapter from the calculus, the right-hand limit or the left-hand limit or the point, all 3 points are very close to each other, right? So technically, a number right to a number left to number, and the number itself is almost same, but not exactly same, right? So as per the perception, for a human observational understanding, can we think of these 3 points as distinct point, or we will believe as one point? Can we really see the difference of the point next to a point and just before the point? The answer is we cannot make such distinction, right? So these distinctions are mathematical in nature. So when I'm saying a point on a curve, I have already taken its neighbor as my triplet. So I'll take a point and its a respective neighbor, and that will give me a triplet of points. Do you realize this, what I'm saying? Hello.
Yes, sir.
So for every point on the curve, the neighbors will be forming a triplet with the given point. Yes or no? For every point on the curve, its neighbor will create a triplet with the given point. Yes or no?
Yes, sir.
So when you talk about this point, it will have its neighbor right and left, and the three will become a triplet. And from any 3 point, how many circle can pass? Only one. But that circle will be unique for these 3 points. So once you draw, you can see this point is on the circle, but the rest of the points are not on circle for the given curve. Once again, once you draw the circle, what you realize that this point is on the circle, but every other point is actually not on the same circle. So where are they? Where are they? And let's try to understand the, a curve, highly curved surface and less curved surface. In case of highly curved surface, which is turning very fast, what do you expect the radius to be? Small or bigger? If a surface is very curved, what do you think about its radius of curvature?
So it'll be small.
Very small. And as it becomes flatter, the radius of curvature will increase or decrease?
Increase.
Increase. So more the flat, more the radius. So what is the radius of curvature of a flat surface?
So infinity.
And this idea is very, very important. If you study the geometrical optics, then a plane mirror is a curved mirror of infinite radius. So it is a spherical mirror of radius infinite. Okay. So can we use the mirror formula for the plane mirror? The answer is yes, we can use. So if you remember the mirror formula in high school, but for plane mirror, and we also know F is R/2, which you studied in class 10th, right? So if R tends to infinity, what will happen? If the denominator becomes infinite, then this term will become 0. And therefore, the V becomes minus U. And you can see that for every object, the image is opposite. Okay. So the value wise they're equal, but sign wise they're opposite. That's why they lie on the two sides of the mirror. And if the object is here, the image will be here. And it is governed by the mathematics. We can also decode that a mirror formula, which we studied for the spherical mirror, we can apply for the plane mirror also, because every mirror is a spherical mirror. Okay. But when we talk about a mirror of this shape, let's say a parabola, then we have infinite circle. So a parabola is not one mirror, not one spherical mirror, but a parabola is infinite spherical mirror collection. So every point on the curve represents one circle. This is what I'm trying to emphasize here. So as you move towards the flatter region, you are moving towards a bigger circle. And when someone is very close to the, a curvy part, I mean, when you are very close to the high curvature, actually that point is on a smaller circle. So if you look carefully, you may realize that as you go away from the vertex, actually you move on a bigger and bigger circle. Do you realize this? A person moving from vertex towards the other end is actually moving on a bigger circle. Correct? Hello,
Yes.
hello, hello. So moving on a curvature or curvilinear track, which is not having the shape of a circle, is like moving on a infinite circle of varying radius. So the first thing you need to realize that a circle is very special. So no matter which kind of curvilinear motion you're trying to study, at one instant, you actually study one circular motion. So when the particle is here, you're on this circle. So this is the circular motion of that instant. But when the particle is here, you're on this circle, doing the circular motion. So every time you walk ahead on the curve, you will find yourself on some circle. And because we can convert every random curve into collection of circles, and because you write the laws of motion only at one instant, you don't write for the entire instant. You write F equals to ma for one particular instant. At one particular instant, the particle will be at one particular circle, for sure, right? So as you're driving on this track, every instant, you will find yourself at one particular circle. Yes or no? Tell me. Tell me, guys, yes or no? Do you realize what I'm saying?
Yes, sir.
So if you are moving on some random curve or random curved track, at any instant, you will be at only one point. Consider yourself as a one point, because I'm talking about the particle dynamics. We replace the body by one point. And if you are at one particular point, so can we say you are at one particular circle or on the circle?
Yes, sir.
And therefore, why we are studying circular motion, that no matter which kind of curve I will introduce in future, at one instant you will be on one circle. So draw that circle and write the laws of circular motion, which you will study here very soon. And that will be the answer. So that is the purpose. And this idea of circle, so when you study the conic section, there is a chapter called circle. And if you really decode the circle, the way I'm trying to explain here in this chapter, so you can take the inspiration from physics and understand the concept of circle. You can solve even a toughest question of parabola, ellipse, hyperbola, if you understand circle really well. Because whether we are talking about parabola or ellipse or hyperbola, they are circles. But circle is unique circle, but other curves are infinite circle or collection of circle. So you might have seen the water pipes. Have you seen water pipes? In the BMC has put a lot of pipe on the road. If you go across Mumbai, you can see a lot of, big pipes. Anyone has seen a lot of pipes kept somewhere on the road?
Yes.
So imagine a guy is jumping from one pipe to the other pipe, because pipes are very close, so you can jump from one to other. So every time you're on a new circle, do you realize this? Your foot is on the new circle. So imagine if I draw circles really close, you won't be able to see the difference between two circles, because the radius will change so smoothly that you won't be able to feel the difference. But you are moving on a different circle of different radii. And what you can realize here, that near the vertex, this parabolic curve has become really, sharp in turn, right? So a sharp turn will represent what? A small circle or big circle? Tell me, guys. A sharp turn is small or big circle? Tell me. Come on. Hello, hello, hello. Am I audible, guys? Am I audible?
So big circle.
Yes, sir.
So as you go towards the vertex or sharp turn, the radius of circle will be lesser or more, bigger. What will be the effect on the radius? It will become smaller or bigger. Tell me, guys. Come on.
So bigger.
So as you go towards the vertex, you are on a bigger circle or a small circle.
Smaller circle.
So the radius will be lesser or more.
Lesser.
So what happened? I mean, you can't see this diagram, and you're answering bigger.
Oh, sorry.
What you were thinking? So as the path becomes more curved, the circle becomes small or big.
Small.
Small.
So don't you realize this part? So a smaller circle represent what? A quick turn or a slow turn? No idea.
It's a quick turn.
A quick turn, very good. So when you are near, if you're trying to negotiate a very sharp turn means what? A turn with a small radius or big radius.
Small radius.
So actually a sharp turn is like a very small radius. And that is very dangerous. Because you will realize that later on, there's the acceleration which you develop or that will develop in order to turn is V square by R. So if you are the rider or the biker or the driver or whatever, V is controlled by the driver, but what about R? R is actually controlled by the curvature. So to make a very sharp turn, the A developed should be, as R will decrease, A will,
Increase.
but we know from Newton's law that to have a greater acceleration, we need greater force. Correct? And the question is, the force is going to be given by the ground, which is the friction force. And therefore, the limiting friction will put a restriction on the AC that can be developed, isn't it? If you remember the limiting friction, do you remember the limiting friction part?
Yes, sir.
Yes.
So ground cannot create beyond certain force. Therefore, you should not turn. You should not make a very sharp turn. If you make a very sharp turn, then the ground cannot provide that force, and therefore the turn will not be achieved. Such turn will not be achieved. In fact, you will go haywire, you will meet some accident. You will hit the other side of the road. So whenever there is a sharp turn, you slow down because you have to decrease the speed in order to keep the frictional force within the limits. That is the whole idea. And this is what we are going to study. So I hope the idea of curvature turn is clear to all of you.
Yes, sir.
So when I'm drawing a path like this, And if the path is not circular, and if I just tell you with your common sense of observation, so which point, if you're moving with constant speed, so at which point it is most likely to fall?
So at R.
Very good. So R is going to be very dangerous, right? So do you all realize that at which point you are most likely to fall?
Yes, sir.
And the answer is? Prasan, sir, what is the answer?
Sir, R.
So is this part clear? Why it is R?
Yes.
Tell me, guys, is this clear to all of you? Or do you have any doubt? So at a very sharp turn, it is possible that the acceleration which is required to make that turn possible may not be provided by the ground contact force, because the ground is having the limitation that it can create. And because of the limitation, there is also limitation on a force, actually, limitation on a circle, also limitation on a radius. So if you see the MotoGP racing, those who drive really fast, they drive on the outer track or inner track.
So outer track.
And why they do so? Because on an outer track, you are moving on a big radius or a small radius.
So bigger it is.
And if R is more, then the AC will be less. The V square by R will be less, right?
Yes, sir.
So if you want to achieve the bigger speed, you should also increase the radius so that you can be turned by the ground friction easily. So if your speed will not match with the ability of the ground friction force, you are most likely to skid or slip away. Understood what I'm saying?
Yes, sir.
Hello, hello. So the takeaway is that every path which is not a circle is a collection of circles. Is this clear what I'm saying? Every path
Yes,
which
sir.
is curved but not a circle is actually collection of circles. So what is the purpose of studying circular motion? The purpose is that no matter what path we have, if we know how to write things in one circle, I can write the laws of motion for any curve, because eventually a curve is collection of circle. Is this clear?
Yes, sir.
Okay. Now we'll try to understand that in circular motion, what happens? I hope, Siddhant, you don't have lecture today, or you have lecture, math lecture.
Sir, I have at 9 chemistry.
Okay, chemistry. So let's go back to the curve path again. I mean, I'll draw the circle. Sometime I'll draw some random path, depending on my mood. So I will always do both. Okay, and now you develop this visualization in your brain that a curve in general is infinite circle. So can you see all those bubbles on a right side path? Mentally, can you develop the bubbles? Hello. Now you have to understand one thing. If I say this as concave, then this will become
Convex.
So this side is concave here. So at this point, you can see this is concave down, and at this point, it is like concave up. And here comes the biggest concept. A curve with both curvature, concave up and concave down. So how we can twist a surface in two directions? So earlier it was turning this way, and now suddenly it is turning this way. Whenever a curve makes a transition of its curvature in terms of sides. So earlier, I think the radius on the concave downside is the center of curvature will be somewhere here. For every point on this path, from A to B, can we say the center will be this side? Yes or no?
Yes.
And then every point from B to C will have center somewhere here. Yes or no?
Yes, sir.
So if A to B is center on this side and B to C centers on that side, so what will happen at B itself? So what do you think? What will be the radius of curvature of B if the curve is turning from there? Any guess?
So will be point sized.
The B becomes exactly flat. The curvature of B is infinite. It's a flat surface. And in maths, we call point of inflection. So if you remember the mathematical tools chapter, I might have discussed that if you draw the y equals to x cube graph, have you drawn the graph y equals to x cube? So this is the graph of y equals to x square, right? Something like this. If you turn the other half on this side, this is something like y equals to x cube, and this point, particularly here, is our great interest. So the point at the center is neither part of the right curve or the left curve. Whenever you change the curvature from concave to convex or convex to concave, the point becomes flat. So this point is actually flat surface. It is like coming here and then becoming exactly flat for some time, then turning. But if I shrink this part as a point, it will look like this. And the point of inflection are flat surfaces. So when we talk about surface, it's a flat surface. And when we talk about the curve, it's a straight curve. Okay. So this is the biggest concept in circular motion, that a point of inflection is the, and because of that, the radius is how much? Infinite. And therefore, at such point, what is going to be the acceleration due to like the turning part? So AC, which we write as V square by R, at this point it will become how much? So the motion described at point B will be rectilinear, not curvilinear. That's very interesting part. So this is the biggest concept of this chapter. So note, motion of particle at point B is rectilinear, not curvilinear. And this will help you in when you write the laws of motion. So at point B, you are supposed to write net force equals to mass into acceleration. Which acceleration? It will be tangential acceleration, the acceleration along the tangent. Okay. So motion of particle at point B is actually rectilinear. So it may be on a curve, but it is not curve. So motion of particle at origin is curvilinear or rectilinear.
So
Rectilinear.
Yeah, so at that point you cannot have the centripetal kind of acceleration, which you might have studied in class 9th or 10th. I hope you are aware of this word, centripetal acceleration.
Yes.
Centripetal acceleration is not acceleration. It is component of acceleration which helps you in turning. Because to turn we need some force, and so we need some acceleration. So the acceleration which helps you in turning is called centripetal. So for example, imagine you are here or you are on any curve path. Let me draw this random curve point. Imagine you are here. So your velocity vector is like this. Because the velocity vector is always tangential to the surface. And if I apply a force like this, and the angle between the force and the velocity is theta. So what is the component of force along the velocity vector?
F cos theta.
And what is the force component normal to the velocity vector?
F sin theta.
Now tell me which component can change the speed? Will make you fast or slow? Think about it. Which force can make you fast or slow? F cos or F sin?
So F cos theta.
Siddhant.
So fast F cos theta and slow F sin theta.
See, fast or slow, both are same. I mean, in this case, it is only fast. F cos theta will make you either fast or slow. I mean, if it is opposite, then it is slow. If it is supporting, then it's fast. What F sin theta will do? Will it affect the velocity?
No, sir, it won't affect.
No, it will affect velocity. It won't affect the magnitude of velocity. Because F sin theta is at a right angle to the velocity. So it is the perpendicular component of force which makes you turn actually. And it is the parallel component which either speeds up or slows down, depending on whether it is supporting or opposing. So what is the acceleration developed by this component? We already consider the net perpendicular component develops an acceleration which we call centripetal. And what the parallel component develop is called tangential. And what force develop is called acceleration. So acceleration acts in the direction of net force. So the AC and AT are convenience in which we break the acceleration into two parts so that we can study each part separately. And the role of AC is to make the turn possible. So AC is responsible for turning only. Responsible for turning. And AT is responsible for change of magnitude. Responsible for change of magnitude. And you should be very careful that when I say acceleration, I talk about in general, and acceleration in curvilinear motion means which can change both actually. Now, when I say a particle is moving with constant speed on a circular track, which acceleration is not possible or should not be there? So you're moving on a roundabout without changing your speed. What you can conclude from there? The force acting on the particle is only changing magnitude, only changing direction, or changing both?
It's only changing direction.
And if it is only changing direction, then can we say that the force is acting always perpendicular to the velocity?
Yes, sir.
You all realize this part, what I said?
Yes, sir.
So whenever you move on a curved track with constant speed, because you can't have constant velocity. So when you move on a curved track with constant speed, the force is always perpendicular to the velocity vector. Is this clear what I'm saying? Hello, hello, hello.
Yes, sir.
Because if the force will have component parallel to the velocity vector, it will definitely change the speed. So whenever we say that a particle is moving with constant velocity, constant speed on a curved track or a circular track, then in that case, the force is always perpendicular. And if the force is always perpendicular, then which acceleration will never develop? Which acceleration will be absent? Which component of acceleration will be absent there?
Tangential.
Very good. So constant speed means there is no tangential acceleration. So which acceleration is there only? Only
Centripetal.
centripetal. Very good. So for example, if you are riding your bike or bicycle, and while turning, you're also pedaling faster and faster. So let's say you're turning on a track and you're trying to speed up. dv by dt is positive. That's called speed up, because I'm writing the rate of change of magnitude of velocity is more, it's positive. It means you are speeding up. This is called mathematically, it's a speeding up, speeding up. So can we say in this case we will have tangential, yes or no? If dv modulus by dt is non-zero, then it means we have tangential acceleration here, yes or no?
Yes, sir.
And because you're on a curved track, so curved track means which acceleration is definite in curvilinear motion, which we cannot ignore at all? Tangential or centripetal? So if you're on a curved track, then which acceleration is inevitable? Tangential, centripetal? Tell me. Is it possible
Sir,
to have,
inevitable as in?
means it will always have non-zero value?
So centripetal.
Yeah. So
Yes, sir.
on a curved track, can we have a situation when there is no centripetal? On a curvilinear motion, is it possible to have a situation when there is no centripetal acceleration?
No, sir.
No, sir.
And we discussed at point of inflection it is possible.
Yes, sir.
So imagine if I draw a curve like this. So you travel here, and then you travel here, you come back. So at this point, the track is this way. The track is actually like this. So this is also curvilinear motion, but at this particular instant, suddenly the AC will vanish. If you remember what I discussed just before. At point of inflection, the centripetal will vanish. Isn't it? Why? Because the moment you change the curvature from concave to convex, you go through the plane phase. Isn't it? Hello, hello, hello.
Yes.
So when you change the curvature, then you go through a transition phase, and at that instant it is possible. But in general, on a curvilinear track, the AC is non-zero. So there is a term called uniform circular motion. And I think your time is up. So we'll discuss this more theory in the next lecture. And we'll start problem solving in next lecture. Bye guys, take care.
Bye,
I'm
sir.
sorry
Thanks,
for
sir.
the delay today. I slept actually beyond my limits. Okay. So you have time to again solve the friction before the next, because 1-2 lecture you will have only theory. So meanwhile the theory is going on here, you can solve more questions. And okay, I'll keep next class on Wednesday. Bye and take care.
Thank you, sir. Bye.